Welcome back to the deep dive. You know,
Oh, this is going to be fun.
it is.
I love this.
Sometimes,
Yeah.
the smallest things
Yeah.
can make the biggest difference.
Absolutely.
And, well, today we are exploring a tool that really embodies that idea, the Vernier Caliper.
That's so fascinating, isn't it? We're talking about a tool that can measure down to like hundredths of a millimeter.
Wow.
Imagine that level of precision needed in, say, building a rocket engine or crafting the delicate gears of a watch.
I'm already intrigued.
Hmm.
I have to admit, though, my own memories of Vernier calipers are a bit hazy.
Yeah,
Something about squinting at tiny lines in a high school physics lab.
I hear you. But those tiny lines, they hold the key to a whole world of precision.
Okay.
A vernier caliper isn't just a fancy ruler, it's a tool that allowed us to move from rough estimations to incredibly accurate measurements.
Okay, so let's unpack this.
Okay.
We've got a stack of research and technical info on Vernier calipers.
Me too.
Our mission, to understand not just how to use them, but why their invention was such a game changer.
Absolutely. And I think the best place to start is with the caliper itself.
Okay.
What are we actually looking at when we hold this tool?
All right, let's imagine I've got one in my hand right now. What are the key parts?
Okay, well, first, you've got the jaws.
Okay.
The outside jaws for measuring external dimensions,
Mm-hmm.
and the inside jaws for measuring internal dimensions.
I see.
Think of it like measuring the width of a block versus the diameter of a hole.
Okay, that makes sense. So we're already seeing how it's more versatile than a regular ruler.
Right.
What else?
Then there's a depth probe
Mhm.
for measuring, depth.
Depth.
Think of slots or holes.
Okay.
And of course, you've got the main scale running along the length of the caliper.
Ah, the main scale. That's the part that looks like a ruler, right?
Exactly. But the real magic happens with that sliding part that moves along the main scale.
Right.
That's where the vernier scale comes in.
Okay, this is where it starts getting a little fuzzy for me. The Vernier scale.
Yeah,
That's the smaller scale with the even tinier markings.
you got it. And this little scale is the key to unlocking that incredible precision.
I see.
You see, the markings on the vernier scale are just slightly different from the main scale.
Hold on.
Yeah.
So we've got two scales
Yes.
with slightly different markings,
Uh-huh.
and that's how we get a super accurate measurement. How does that even work?
It's pretty ingenious, actually. It's like having a zoomed-in ruler,
Oh, okay.
helping you pinpoint the exact measurement between those larger markings on the main scale.
Okay. All right. I'm definitely going to need a visual on this.
Yeah.
But before we get into how to actually read the scales,
Yeah.
tell me, how long has this tool been around?
That's where it gets really interesting.
Okay.
This isn't some newfangled gadget.
Right.
The vernier caliper was invented way back in the 17th century. Can you believe that?
Wow. The 1600s.
Yeah.
That means this tool predates electricity, modern manufacturing,
Oh,
pretty much everything.
exactly. A French mathematician named Pierre Vernier
Okay.
came up with this brilliant solution to a problem that was plaguing folks at the time:
What was that?
how to get more precise measurements.
Makes sense.
Yeah.
I can imagine that would be a problem.
Oh, yeah.
So think about it. Back then,
Hmm.
they were building things like cathedrals and ships.
Yes.
And they needed accuracy, but they didn't have the tools that we have today.
Precisely.
Amazing.
And the Vernier caliper was a huge leap forward. It allowed them to achieve a level of precision that was previously impossible.
Yeah.
It really was a game changer.
Okay, now I'm even more curious to understand how this secret decoder ring of a scale actually works.
Yes.
Let's dive into that next.
All right, you game for a little measurement mystery.
Oh, I like this.
Let's imagine we're back in the 17th century, pre-electricity,
Okay.
and we're tasked with building a beautiful clock.
Ooh, I like this.
So we've got gears,
Yeah.
springs, all these intricate little parts,
Real-
and no lasers or digital readouts to help us.
Exactly. We need to make sure each piece fits perfectly,
Mhm.
or our clock won't keep time.
That's right.
That's where our trusty Vernier caliper comes in.
Yes.
Okay, so I'm holding my caliper.
Okay.
I've got one of those tiny clock gears nestled between the jaws.
Yeah.
What's the first step?
First, focus on the main scale, the one that looks like a regular ruler.
Okay.
Read the measurement to the left of the zero mark on the vernier scale that gives you the whole millimeter.
Okay, let's say it lines up with the 12 millimeter mark.
Okay.
Wait.
Ooh, now comes the fun part.
Okay.
Look closely at the vernier scale
Mm-hmm.
and find the line that lines up perfectly with the line on the main scale.
Okay.
It's like a little puzzle.
Okay, I see it. The fourth line on the Vernier scale is in perfect alignment with a line on the main scale.
Uh-huh. That 4 is your key.
Okay.
Each line on that vernier scale represents a fraction of a millimeter, usually 0.1 millimeter.
Okay.
So since your line was the fourth one, you add 0.4 millimeters to your main scale reading.
Wait, so my total measurement is 12.4 millimeters.
You got it.
That's way more precise than I could get with just eyeballing it on a regular ruler.
That's the brilliance of the Vernier scale. It lets us bridge that gap between the larger markings on the main scale.
Yeah.
And guess what? Back in the 17th century, this level of precision was revolutionary.
It makes you wonder how they managed before. I mean, could you imagine building a cathedral without being able to measure things accurately down to the millimeter?
It would be chaos.
Yeah.
This tool wasn't just about convenience. It enabled entirely new levels of craftsmanship and engineering.
So thanks to Pierre Vernier and his clever little scale, we could start building more complex machines, more intricate devices, things that wouldn't have been possible before.
Precisely. And this need for precision just kept growing.
Right.
As technology advanced, we needed to measure even smaller things with even greater accuracy.
That makes sense. Think about microchips and computer components. Those things are tiny.
Exactly. And that brings us to the digital age. While we've been focusing on the analog Vernier caliper,
Right.
it's important to mention that the invention of the digital caliper has made things even easier.
So instead of squinting at tiny lines and doing that mental math, we get a clear digital readout. That sounds pretty convenient.
It is, but here's the thing.
Yeah.
Digital calipers still rely on the same underlying principle as the analog version.
Okay.
They just have a tiny computer inside that does the calculations for us.
So even though the technology has evolved, the core concept of Pierre Vernier's invention is still at the heart of it all.
Absolutely, and that's why understanding how the analog version works is so important.
Right.
It gives you a deeper appreciation for the ingenuity behind it.
Speaking of ingenuity, you mentioned earlier that the Vernier caliper's impact went beyond clocks and cathedrals.
Yes.
What other industries were revolutionized by this level of precision? Well, I'm picturing all sorts of industries. What about something like shipbuilding? I imagine needing precise measurements to make sure all those pieces fit together perfectly.
You're absolutely right. Shipbuilding was definitely impacted, but think even smaller. The invention of the Vernier caliper played a huge role in the development of firearms.
Whoa, I wouldn't have thought of that. How so?
Well, to create firearms that were actually accurate and reliable, you needed to be able to machine parts with incredible precision. The Vernier caliper allowed gunsmiths to achieve tolerances that were previously unheard of, leading to a whole new era of firearms technology.
So we're talking about a ripple effect, right? This one tool led to advancements in so many different areas.
Exactly. It's like a chain reaction of precision, and the impact goes beyond just creating things. What about scientific discovery?
I'm seeing a connection. If you're trying to study the natural world, being able to measure things accurately is crucial.
Precisely. The Vernier caliper opened up a whole new world of possibilities for scientists, allowing them to take more precise measurements of everything from plant growth to the movement of celestial bodies.
Wow, from guns to stars. It's amazing to think about how one seemingly simple tool had such a profound impact on so many different fields.
It really is a testament to the power of human ingenuity, and it makes you realize that sometimes the most groundbreaking innovations aren't flashy or high-tech, but rather simple, elegant solutions to fundamental problems.
You know, it's funny, we've been talking about this tool as if it's a relic of the past, but Vernier calipers are still widely used today.
Absolutely. They might not be as common in everyday life as they once were, but in fields like engineering, manufacturing, and even medicine, they're still essential tools.
And even though we have digital calipers now, I bet those who use them regularly still have a deep appreciation for the analog version.
I'd say so. There's something satisfying about being able to read a Vernier caliper and understand the mechanics behind it. It's like a little piece of history you're holding in your hand.
So we've gone on this incredible deep dive into the world of the Vernier caliper, exploring its history, its mechanics, and its impact on the world. But before we wrap things up, I want to leave our listeners with a thought.
What's fascinating here is the ripple effect of this one invention. So here's a question. What other seemingly simple tools or inventions have had an outsized impact on our lives? Take a look around you at the objects in your home, the technologies you use, think about the history behind them. You might be surprised by what you discover.
It's a great reminder that innovation can come from unexpected places and that the smallest tools can sometimes have the biggest impact. That's it for this deep dive. Until next time, keep those minds curious.